Hey guys, Garrett here, and today I want to talk about concrete and rebar as they are used in ICF applications. Now, I'm a licensed professional civil engineer, so I'm pretty comfortable talking about the concrete as well as the rebar. I didn't have a problem designing my own house. Now, I would still talk to your local jurisdiction, figure out what their code requirements are going to be with this ICF. A lot of jurisdictions don't have a lot of experience with ICF, but they're definitely willing to work with you, and if you need to, contact an engineer in your own town or city. First, we're going to talk about concrete, and the ICF manufacturers generally recommend a minimum of 2,500 psi concrete. That's 2,500 psi of compressive strength, and a lot of people get fixated on the higher the number, the better it's going to be. You trade off things as you go with higher strength concrete, including cost. It gets a lot more expensive the higher the strength of the concrete. And let's be realistic, you're building a home. The loading on that structure is very low. You just don't need that high of strength of concrete. So their recommendation of 2,500 psi isn't that terribly far off. I went with 3,500 psi concrete with fly ash and air entrainment. And I did it at a 6-inch slump. And for my 8-inch core basement blocks, I just used the normal aggregate that was in it, anywhere from 1/2 inch to 3/4 inch aggregate. And I'd recommend anyone with 6-inch core or smaller block to use 3/8 inch maximum aggregate on your concrete mix that you're going to place in those walls. The reason being is the larger aggregate can actually get caught between either multiple pieces of rebar or the rebar itself and the side of the blocks, and then you don't get good consolidation of that concrete within your walls. So you want to go with the smaller aggregate so that it can flow into all of those nooks and crannies. Just remember to design your concrete mix based on your loading conditions. Don't think anything beyond that. I went with the 3,500 pound mix partly because we're in Tornado Alley. There's always a chance of tornadoes as well as high winds. If you are on the coast and you have hurricanes, that sort of stuff, higher strength concrete is not a bad way to go. But to be honest with you, the vast majority of your strength in those applications is going to come from the rebar placement. Remember that your ICF blocks are actually going to create an almost perfect environment for that concrete to cure. The moisture is held within that cavity and it doesn't really have a way to evaporate, which then speeds up the curing process. It actually creates a very slow curing process, which is the best for concrete, and it has very little temperature fluctuation as it is curing. So you're going to get almost a perfect cure out of the concrete that is within those walls. And because of that, you don't have to use such a high strength mix. Now let's move on to rebar, and that is a very important thing that we need to talk about. I use number 4 bars throughout all of my walls as well as my footings. My footings themselves actually had number 5 rebars, but I used a number 4 rebar just like this. I cut it at 36-inch lengths and then bend it 90 degrees at the 8-inch mark. So that meant that I could stab the short end into my footing before it had time to cure and have at least 24 inches of it sticking up out of that footing that then would be engaged by the vertical rebar that is in the ICF blocks. One tip I want to give you for the concrete that is sticking out of that footing is to make sure that you mark on the footing outside of where your blocks are going to be that exact location of the bar. That way, whenever you thread your vertical rebar in place, you're going to be getting it very, very close to where that vertical rebar is that's sticking out of your footings. You want to get them as close as possible. I used build block ICF blocks, and they have webs every 6 inches. So I went ahead and made my vertical rebar every 18 inches. And then I placed the horizontal rebar on every single course of the block as it went up. Another tip for you is to stagger that horizontal rebar. Just one place off will give it enough space so that you can thread that vertical rebar right through it and it's held perfectly in place. Also, place that horizontal and vertical rebar on the interior half of that block. And the main reason is there's nothing on the inside of your house that is pushing out, but there's always some kind of a force that's pushing in from the outside. It could be wind, or it could be dirt, soil if you're building a basement. By placing it on the interior half of that section of wall, you're actually going to strengthen your wall. The rebar, since it is placed furthest away from that continuous load, is actually going to be at its strongest point because it is furthest away. So that means it actually puts it in greater tension, again, giving your wall more strength. Also, your walls are going to be a little bigger probably than what your typical stick of rebar is going to be. Most of the time it comes in 20-foot lengths, meaning that you're going to have to overlap those joints. The typical rule is 40 times the diameter is what that overlap should be. So if it's a number 4 bar, half-inch bar, it needs to be at least 20 inches of overlap to be adequate. And generally, you're going to overlap that bar as a contact joint and then just tie it together. With ICF, you can actually do a non-contact where you actually put it in the next nub, and that's fine too. I'm not going to get into the lintels that you're going to have to build over your windows and your doors. That is definitely something you're going to want to contact your engineer about. But definitely don't forget those. That could be a very bad failure point for either the roof loading or even the floor loading. I used grade 60 steel. You can use higher grades if you want, but at least for my application, it just wasn't necessary. That grade 60 was perfectly fine. I also placed 2 number 4 bars at the very top of the wall, just for a little extra strength, exactly where that loading is going to be with those roof trusses. Now let's get on to the actual pour day. Now make sure you definitely have inspection holes underneath each of your window bucks. My general rule would be if the window is less than 3 feet, you can have 1. If it's between 3 feet and 6 feet, you could have 2. Basically, every 3 feet, add an inspection hole. And when I did mine, I used a 5-inch hole saw for it. I also burned up my Makita drill on the way, so I ended up having to buy a DeWalt drill. And I honestly don't think that it needs to be a 5-inch hole. We didn't actually pour concrete through that hole. We just stuck the concrete vibrator through it to draw that concrete in and fill all of those voids. So realistically, I think a 4-inch hole saw would probably be even better, and it's not going to kill your drill. Your concrete pour day is going to be one of the most stressful days that you have. Make sure that you have extra help. And it's fine if you have pizza and beer, but do not do that unless all of that concrete is in place and you are done with everything. You're going to want to have a couple of people adjusting your bracing. You're going to want to have at least 1 or 2 people vibrating concrete. You're gonna probably be the one yourself that's moving around the concrete chute for the pumper truck. And then you need probably a couple of floaters that can just help. If you have a blowout of some sort, make sure that you have some extra lumber and screws in place so that you can quickly patch that and get on with the pour. And if anyone tells you, you place concrete, you don't pour it, it just doesn't really matter. Several rules when you are placing that concrete in those walls with that concrete pumper truck. You got to remember that that concrete comes out at a very high velocity and it has a lot of power whenever it hits. So you want to be moving that hose all the time. Also, you want to make sure that you place this concrete in lifts. My walls were roughly 10 feet tall, so I ended up just doing 2 lifts. Some people would say I should have done 3. It really doesn't matter. If everything is holding together, you're probably just fine. Just kind of watch it and you'll get a feel for what you can get away with. But when you get close to windows, doors, and corners, there are very specific rules you need to follow. When it comes to a window, you want to actually kind of push that concrete underneath the window and then work side to side on that window. You don't want to push too much concrete on one side of the window or it could actually throw you out of square in that window buck. So just move that hose side to side on that window as you are getting the concrete in place, and make sure that your person with the vibrator is using that inspection hole down below to draw that concrete in. To be honest, you don't have to over vibrate this. That concrete, once it hits that vibrator, it really consolidates everything in, and it does it very quickly. Your corners are also going to be weak points. So as you come up to your corners, you want to stop 3 to 4 feet short and actually let the concrete build and flow around that corner. Let it flow for a little bit, work your way to the other side of it, let it backflow, and then just move on. You don't want to hit those corners just dead on with that concrete that comes out of that pumper truck. It has the potential to blow that entire corner apart, so it's just not worth taking the risk. Make sure that the person that's running that concrete vibrator does not leave it in one place too terribly long. You want them to thread it all the way down and then pull it all the way back up. Move over a foot, thread it all the way down, pull it all the way back up. Do not dawdle, or else your large aggregate are gonna settle out to the very bottom of it and you're going to lose strength in the wall in that section. Quick tip, if you're filling your basement blocks, there's 2 things you should do. You should definitely stop the concrete pour in about the mid-block portion of that top block. If you get too close to the connection point, that's a weak point and you could blow those out whenever you place the concrete in the next set of blocks. So make sure you stop it midway in that upper block. Also, you want to keep the nubs of that top row very, very clean. And I just used painter's tape and actually covered all of those nubs as I went before we did any of the concrete placement. Once the concrete was in place, we just removed that tape and those nubs were nice and clean so that we could just almost immediately start stacking the next blocks. Once you have made it to what we're going to call the finished top, this is where the actual roof is going to set on those blocks. You're going to finish that whole thing nice and flat, but do not forget your J-bolts. Make sure before you get to concrete pour day, you know exactly where these J-bolts need to go. You're gonna mark them on your blocks so that there is no question of where they need to go. Most code states you need them every 6 feet. I did it every 4 feet. And also remember that you might want to have your diagram for where your roof trusses are going to go so that none of them sit directly on this J-bolt. So good news, now the concrete's in place. It's basically a bit of a waiting game. If you're doing the basement pour at this point, I would work on the waterproofing on the outside of it. It's a great time to do that. Do not, under any circumstances, backfill anything less than a week out from your pour. The longer you can let that cure, the better off you're going to be, and the less chance you have of cracking or even micro cracking that concrete. So a little more time is better, as well as any loading that you're going to put on top of it, whether it be the floor trusses, the roof trusses, things like that. There's always going to be plenty of things around the job site that you can work on during this cure process. And if you're pouring concrete during the winter, the nice thing again is those ICF blocks create an excellent environment for that cure process. But it'd still be a good idea to cover the concrete that's at the top of those blocks that is exposed to the elements. Remember, concrete curing is an exothermic process, so it does give off heat. The chances of your concrete freezing are basically none, but still it's better to be a little bit overprotective, especially that very top layer where that loading for your roof trusses is going to sit. Your concrete pour day is going to be very stressful, and there are a few things that are just going to end up being out of your control because you are part of the crew that is actually putting that concrete in those walls. And one of those things is the concrete that comes on site. So you may order it with a 6-inch slump, but it may show up and it's only 5, and the concrete pumper truck needs something that's more than that. A lot of times they're just going to add water. So again, getting a mix that is a little stronger than what you really need is not a bad thing, because if they put extra water in that mix, since you ordered a stronger mix to begin with, your average strength at the end of it is going to be satisfactory, unless you give them very specific directions to only do admixtures of some sort. It could be super plasticizers, basically anything that's going to give you a higher slump without decreasing the strength of your concrete. Now remember, that does actually cost a lot more money whenever you are adding those additives to it. So you have to factor that in. However, if you do get a mix that is stronger than what you need, and you assume that a little bit of water is going to be added to it, you're just going to be fine. Triple check your concrete quantities before the day comes that the concrete is actually on its way. You absolutely do not want to run out of concrete before being done with this. With that said, most likely you're going to have leftover concrete, so a good idea, especially if you have a shop like I do on my property, I would generally form out some sort of a sidewalk or a pad or something like that that I could put the extra concrete in that was left over. And I was able to get some sidewalks out of it. I was able to get a pad in front of the door to my shop, as well as kind of a driving entrance going into my shop. So it was well worth doing that. Just remember, you paid for that concrete whether you're using it or not. So you might as well use it. Make sure to smash the like button down below, as well as subscribe for more great content like this. I'll see you next time.